Well, hey there, kiddos. Welcome to your very last video of the first semester. This is going to go pretty fast because I'm going to sort of rush through these because you practiced a lot of this during class today as you were making the triangle. So for those of you who struggled making the triangle, please make sure you take very, very good notes. For Molly's team, who actually completed the triangle and got it all correct, good job. That was absolutely fabulous. Just make sure you take really good notes because you will practice this some more tomorrow. So remember some things to know. First of all, what do you know about the slopes of parallel lines? Well, slopes of parallel lines are always the same. Slopes of perpendicular lines are what we like to call opposite reciprocals. And if you'll remember, what that means is they are flipping opposites. So you got to flip them over and change the sign. And if you want to check to make sure lines are perpendicular, then multiply their slopes and that equals -1. So the product of their slopes is -1. So if you multiply them together, it'll always equal -1. So let's whiz through a couple of examples really quick. So number 1 says, write an equation in slope-intercept form, so we want it to end up looking like y equals, for a line that passes through this point and is perpendicular to this line. Well, before I can find the slope, I need to solve this for y. Y has got to be by itself. That is the only thing that you didn't have to do today when you were doing these problems. So we're going to get y by itself first by adding x to both sides. So I have 3y equals x plus 6. And then I'm going to have to divide everything by 3. So I end up with y equals, there's a 1 in front of this x, it's invisible, but there is a 1, so this becomes 1/3 x plus 2, because 6 divided by 3 is 2. So my slope for this line is 1/3, which means a perpendicular slope will be, flip it over, change the sign, so it'll be -3. So I'm going to have to use a slope of -3 and this point. So I'm going to go back to point slope form, which is this equation, y minus y1 equals m times x minus x1. We're going to need to use that formula in order to write our equation. So I'm going to have y minus 1 equals my new slope, the perpendicular slope is -3 times x plus 3. We're going to distribute, so I have y minus 1 equals -3x minus 9. And then I'm going to add 1 to both sides so that it's in slope-intercept form. So I'm going to end up with y equals -3x minus 8. This line will be perpendicular to the line that they originally gave me. If I were to graph them together, they would be perpendicular. They'd cross at a right angle. So let's look at number 2. Number 2 is similar. It says write an equation again in slope-intercept form for a line that passes through this point and is parallel to this line. So now I need them to have the same slope because they're parallel, but first I got to know what the slope is, so I've got to solve for y. So I'm going to subtract 4x on both sides, so I end up with -y equals -4x minus 5. And I can't have a -y, so I'm going to multiply this whole thing by -1, which gives me y equals 4x plus 5. So my slope for this is 4, which means my parallel slope is also 4. So I'm going to use a slope of 4 and this point. So I have y minus -8, which is y plus 8, equals, this is not an 11 by the way, that's the symbol for parallel. My slope of 4 times x minus 4. This 4 is the slope, this 4 came from my point. I'm going to distribute, so I have y plus 8 equals 4x minus 16. And then I'm going to subtract 8 on both sides, so I'm going to end up with y equals 4x minus 24. So when I subtract 8, it just gets smaller, and so this is my equation. This line is going to be parallel to this line. They will never ever cross. And so number 3 here says to write an equation, again in slope-intercept form, of a line that passes through this point, -2, 3, and is perpendicular to y equals -5. If you will remember, if an equation is just y equals, that means it's a HOI, so it is a horizontal line. The only way to be perpendicular to a horizontal line is to be a vertical line. So what I need is a line that is vux. And so it has to be x equals. Well, if you look at the point that you are given, x in that point equals -2, which means to be perpendicular, x is going to have to equal -2. It doesn't have, well, in order to pass through that point, it does. So x will equal -2. That's your equation. So now number 4. We want an equation, again in slope-intercept form, of a line that passes through this point that is parallel to y equals -7. So now what I have is a horizontal line, and in order to be parallel, I need another horizontal line. So now instead of x equals, I'm going to have to write y equals because they should look the same. And if I look at the y coordinate of my point, it equals -2. And so that's how those work. If you need to learn, y equals means horizontal, x equals means vertical, and so you need that's something you need to memorize. That Hoy-Vux thing needs to be burned into your brain, and what they stand for needs to be just something you know. So number 5 here, we want an equation, slope-intercept form, for a line that passes through 1, 1 that is parallel to this line. Well, they've given you the picture. What we're going to do is find the slope, because that's what we need to know is the slope. So I'm going to find 2 pretty points. I'm going to draw my right angle so it looks like I go up 1, 2, 3 and over 1. 1, 2, 3, and yep, so my slope is 1 and my point is going to be 1, 1. Now I could graph it and then write my equation, but we're just going to plug it in. So again, we go back to our point slope form and go y minus 1 is equal to 1 times x minus 1. All those ones, they made this so easy. And it's not 1, it's 3. I'm sorry, I wish that I could hear y'all yelling at me all the way through the video. My slope is 3, not 1, because it was 3 over 1. Glad we didn't get all the way through the problem without me fixing that. So I have y minus 1 is equal to 3x minus 3. We want to get y by itself, so I'm going to add 1. So I have y is equal to 3x minus 2. This right here would be the equation of the line that's going to be parallel to that one. And if I graph it, it should be parallel. And you can test it real easy by getting out a pen and actually graphing it. So the y-intercept's at -2. It has a slope of what? 1, 2, 3 and over 1. 1, 2, 3 and over 1. And if I connect those points, even though I can't draw very straight, you should see that those lines end up parallel. They're not going to cross one another, and that's because their slope is identical. So let's do one last problem. Number 6. The reason I have this on here is because this is how this question, it shows up on standardized tests, like the STAR test. So, which of the following describes a line passing through 3, 3 that is perpendicular to this line? Well, the first thing you need to do is get this so it is y equals so you can find your slope. So we're going to do that. So over here, I'm going to write, I'll do it right here, 3x minus 5y equals -10. I want y by itself, so I'm going to subtract 3x. So I have -5y equals -3x minus 10. And I'm going to have to divide everything by -5. So I get y equals -3 and -5 make a positive 3 over 5 because the negatives cancel. And then -10 divided by -5 is positive 2. So there's my equation. I need a perpendicular line. So the slope of this is 3/5. This slope is 3 over 5. But what I need is the perpendicular slope. So I have to flip this 5/3 and change the sign. So my flipping opposite slope would be -5/3. So if you look at the answer choices that I have down here at C and D, where they have written the equation out, if you will notice, D has the wrong slope. It says 3/5 x. Well, that would be if they were parallel. This is close. It says 5/3, but they didn't change the sign. And so that's also not correct. So it's going to be one of these two. So let's just check our slopes for our lines. Let's start here and we'll count down 1, 2, 3, 4, 5, and over 1, 2, 3. Look, I'm not even at a point on the line. Here, if I go down 1, 2, 3, 4, 5, and over 1, 2, 3, look, I have now hit a point on the line. And if you'll notice, both times I started from the y-intercept because I knew I had a point there. So from here, I counted down 5 and over 3, down 5 and over 3. This one doesn't work. This is the only one that does. And so that's what they're asking. And if you will notice, this point that I just counted to happens to be that point 3, 3. which is the point they said it had to pass through. That's the other thing that you can look at before even going to finding the slope. At this point right here, 3, 1, 2, 3, look, it does have a point there, but it doesn't have the correct slope. So this does pass through that point at 3, 3, and has a slope of -5/3. So this is perpendicular to this one. So that is how we do that. It's what we're going to practice again tomorrow. So again, Ellie's group, who did really fabulous, Molly's group, who did really fabulous today, y'all should do pretty well. Everybody else, please make sure you took very good notes. I'm not saying that you didn't do very well today. I just know that Molly's group finished the triangle and got them all correct. So make sure you're taking good notes. I will see you tomorrow. Have a good day.